Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another lead code problem, that is trapping rainwater. It's a hard level question and it's a very popular question, as you can see from the likes. So let's read the problem statement. Given an n non-negative integers representing an elevation map where the width of each bar is 1. Compute how much water it can trap after raining. So we are given with an elevation map, and and if you can see, the water is trapped between the bars, where bars acts as a container. So 6 unit of water is stored or is captured after raining. So 1 unit of water at 2 here, and 3 and 4 units of water in this portion, and 1 unit of water at this index. So total 6 unit of water is trapped. So we will solve this problem. So we will solve this problem using dynamic programming, that is DP, right? So I have taken this example, this elevation map, where each bar is represented by the black color and each blue portion represents the water trap. And the width of each black portion or the bar is 1 unit. So if we observe, right, so at any index I, the bar on the left and bar on the right will represent as a height for the container that will store the uh, amount of water at the index I, right? So the amount of water stored at index I will be the area of the that portion, which will be nothing but height into width, where height is the height of the water that will be stored in at index I, and width, as we know, for the each bar the width is 1. So the width of each index, right, will be 1. So area will be height into 1, which will be nothing but the height. So if we can calculate the height at any index, that will be the area or the amount of water stored at that index. Now we want to calculate the maximum area at a particular index. So we will take the maximum height of the bar on the right side of the index I, right? And we have to take the maximum height of the bar on the left side of the index I. And we will take the minimum of the two max, right? And we will take the minimum of the left max and right max, because the maximum amount of water that can be stored, the maximum height of the water that can be stored, it will be equal to the minimum height of the either of the left or the right bar, right? So at any index, the amount of water that will be stored will be the minimum of the left max, right? Left max represents the maximum height of the bar on the left side of index I, right? And on the right, and right max represents the maximum height of the bar on the right side of index I, right? We will take the minimum of both and we will subtract the current height, right? And we will subtract the current height of the bar. So let's see an example. Let's see for some indexes. For example, for index 2, right? We want to calculate the area of the water or the amount of the water. So we need to calculate only the height, as we know the width will be 1. So as width of each bar is 1. Now to calculate the height, we will first have our left max. So left max represents the maximum height of the bar on the left side of the current index, including the current index, right? Including the current index. And right max represents the maximum bar height right side of I, including the current index. So at index 2, what is the left max that we have? It's 1. This is the maximum bar that is available on the left side of index 2, that is of height 1, right? And what is the right max that is available on the right side of 2, including the current index? So current index bar at the current index 2 is 0. The height of that bar is 0, and the right side, the maximum height of the bar is 3. right, at index 7. So we will take the minimum of 1 comma 3, that will be 1, and we will subtract the height of the bar at the current index. So current index height is 0, so we'll subtract 0 and that will be 1. So 1 unit of water will be stored at index 2. Now to calculate at index 4, let's calculate at index 4. Now on the left side, the maximum left max is at index 3, right, that has height 2. Now for the right, the this is again at 3 in at index 7. So the minimum of this two will be 2, and the height, now at index 4 we have a height, bar height as well. So we'll subtract minus 1 because the height of the bar is 1. So it will be 2 minus 1, one unit of water that will be stored at index 4. So likewise we will maintain a left max and the right max array for each and index, and we will store the maximum height of the bar at index 0 including the current index, and similarly the right max for the current index including the current index, right? So at 0 the bar height is 0 and on the left side there is no bar, so the current left max for this index 0 is 0. What will be the next left max for 1? So as the current height is 1 and on the left side the bar height is 0 at index 0, so the current height is 1 which is greater than 0, so we'll take 1 as the left max for the index 1. Similarly for 2 it will be 1 because the current height is 0 and the on the left side that is 1. For 3 it will be 2 as the current height is 2 and on the left sides there is only a bar of length that is 1, right? So we will take the current height. Similarly for index 4 it will be 2, index 5 it will be 2, 6 it will be 2. Now at 7 as the height increased, so it will be 3, right? As the current index 7 the height is 3, so the left max will be 3. Now for 8 it will be 3, 3 onwards, right? Because for all the indexes from 8 to 11 the left max is 7. Similarly we will maintain right max but starting from the last index. So at the last index, as the current index is 11 and on the right side there is no bar and the current height is 1, so the right max will be 1 for the index 11. For the 10 it will be 2, for the 9 it will be 2, right? Because the current height is 1 but the left max is, right, 2, because there is a bar at index 10 that has a height 2, so we will take left max at index 9 as 2. Similarly for 8 it will be 2, for 7 it will be 3, right? For 6 it will be 3, 3, 3, 3 on, right? For all the other indexes 3, because say for at index 4 the bar with the maximum height is at index 7, that is 3. So the same we have represented in a graph the left max and the right max. As you can see, for the left max at each index, at index 0 is 0, at index 1 it's 1, at index 2 is 1, and index 3 is 2. Then at index 4 it's again 2 and 2 till 7, and after 7 it's all 3, right? At and similarly the right max that is starting from the last index, it's 1 for 11th index, then for 10 it's 2, then 2 till 8, and on 7 it's 3, and then 3 till 0, right? Now we will calculate the minimum. We'll take the minimum of left max and right max and we will subtract the current height. So what is the minimum of 3 and 0? It's 0. And what is the height, that is current height, that is 0. So 0 minus 0 will be 0. What is the minimum of 1 and 3? 1 and 3 is 1 and the current height is 1. So 1 minus 1, that is 0. What is the minimum of 1 and 3 at index 2? That is 1. And what is the height? That is 0. So 1 minus 0, that is 1. So 1 unit of water will be stored, right? At index 3, what is the minimum of 3 and 2? 2. And what is the height? That is 2. So it will be 2 minus 2, that is 0. Again at 4, what is the minimum? 2, 2. What is the height? 1. So 2 minus 1, that is 1. So 1 unit of water will be stored. Here 2 units of water will be stored, so it will be 2, right? For index 6 it will be 1, so 1 unit of water. For 7 it will be 0, 8 it will be 0, for the 9 it will be 1 unit of water, so 1. For 10 it will be 0 unit of water, and for 11 it will be 0 unit of water, and total it will be 6, right? So this is what we have represented in the third graph. So this this graph represents the intersection of the first two graphs. This shaded region is the intersection, is represented by minimum of left max comma right max minus height I, right? So suppose at index 5 the left max is 2, right max is 3, but we will take the left max, that is 2, right? So let's see the code part for it. So I have taken a class solution, right? And I have created a function that is trap that takes in the height. I have taken the two arrays, that is left and right, that will maintain the left max and the right max at each index. So these two loops calculate the left max and the right max at each index. So we'll start from I equal to 0 till height dot length. So we will take the maximum of the maximum till that index, comma, the height of that current index, and we will update the max, and we will take that max as the left of that current index. And similarly we will update the right array for the each index, but we will start from the last index till 0. And finally in the last for loop I will iterate from I equal to 0 to height dot length, and will take the minimum of left and right, and will subtract the height of the current index, and we will add the resultant value in a result variable, and we'll keep on adding till the for loop is completed, and we'll finally return the result. So let's run the solution. So yeah, test cases are accepted, it means solution is working fine. So let's see, talk about the time and space complexity. So as you can see, we are running, I mean, 3 for loops in one pass, right? So we are iterating every time in this for loop till n, where n is the height dot length. So the time complexity will be in worst case big O of n. For the space complexity, as we are maintaining two arrays of length n, so the space complexity will be order of big O of n plus n, that will be big O of n. So I hope you enjoyed watching this video. If you like this video, please share and subscribe. It will keep me motivated to bring more such videos on various concepts of algorithm and data structure by solving various questions on Leetcode. Thanks for watching. Bye.